In today's video, I would like to show you how I added scale to a 3D model of the Crenshaw wall. This is an art mural painted in Los Angeles. You can learn more about this mural at crenshawwall.org. My friend Danielle had the idea for this project about a year ago, and I was really excited that she asked me to help her. I feel that it was a really great collaboration, and we were looking for more historical art preservation projects, so please list ideas that you want to share in the comments. We are planning additional videos detailing the entire process for capturing the wall, but I wanted to start with a short video on how to capture scale markers and the method we used for scaling the wall to the proper size. The first step is to take pictures of the markers, and so let's see, you can see here that these are some pictures with the markers. So these are the markers that we are using. So I've already done the next step, but the next step would be to go to workflow and align photos. This has already been done, so we don't need to do that again. After doing that, you can optimize your camera placement, remove low quality points, optimize camera, and also gradual selection to remove the low quality points. But that's already been done, and we're in a good shape on this model. I've already completed those steps, and so I'll skip directly to marker detection. So here, to go to marker detection, we go to Tools, Markers, Detect Markers. The markers that we're using in this case are circular 12-bit markers, but other types are available. Use 14-bit, 16-bit, 20-bit, cross non-encoded, circle. Tolerance, a good place to start off with this is 50, but this can be increased if not all markers detected. Leave inverted unchecked and click OK. If you don't have this feature, it is most likely because you're using Metashape Standard and not Metashape Pro. On the Agisoft website compare page, you can see features not supported in the standard version of Metashape. In this case, we are using a set of professionally calibrated scale bars for highly accurate measurement created by Cultural Heritage Imaging, also known as CHI. They are accurate to 1/10 of a millimeter and printed on aluminum for durability. CHI provides a detailed user guide for how to use their scale bars for obtaining high accuracy. There are 3 coded markers on each of 4 scale bars. Now we'll just wait for this to complete, and then we can see how well our detection processed. Okay, so that worked. We can see here that 11 markers were detected. There are 3 coded marker sets, so let's zoom in. Target 65. We can right click here and we can do filter photos by markers, and then we can see the markers here. So in this model we have 3 coded markers on each of 4 scale bars. 11 markers should be detected. Marker 67 is obscured by grass. 65, 66, 67 would be right here, but it's not detected. Marker orientation can be seen on this image. And this is marker 68. And the pixel radius is 12 pixels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so the pixel diameter is about 25 pixels. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. One interesting phenomenon here is the different color on the top of the marker versus the bottom. You can see here we have this purple color. Down here we have this green. This is chromatic aberration, which is a failure of the lens to focus all of the colors of an image to the same point. This is mainly transverse chromatic aberration, since the image is in focus and the aberration occurs from inside, more purple, to outside, more green. You can see the center of the lens axis is here. Comparing marker 68, which is almost directly below the center axis of the lens, and marker 65, nearly directly left to the center axis of the lens. You can see here, on this side, purple, this side, it's green. And so, now we have a couple of other images that I'd like to show, which are 7353. You can see here green on this side, purple on that side, and then compared it to 7357, purple on this side, green on this side. And you can see that that's because the lens axis is over in this position, and in 353 the lens axis is in this position. So whichever side is closer to the lens axis is purple. Overall, the software did a good job of picking out these markers. So the next step is to create the scale bars. To create a scale bar, we're going to click here, and then we're going to do Control, Shift click when they're both highlighted, and click on Create Scale Bar. So we're going to do this for all of the scale bars that we're going to access, 65 to 66. Then we're going to do 68 to 69, 69 to 70, 73 to 74, 74, 75, 76, 77, 77, 78. So we click here, view source, and then we type it in. These are all values that are recorded on the scale bars themselves. (73 to 74). Okay. This is the error measurement, and this is the estimation of where it believes the scale bars should be positioned. So you can see that based on what we entered and the accuracy and then the error right here. So it looks like some of these we have 8 millimeters of error here, 8 millimeters here, and the ones on the far side of the model, so you can see here, these are quite a distance away for targets. Right here. So using 76, 77, and 78 as the reference scale bars, you can see how accurate your measurement is. So it looks here like there's about a 10 millimeter error to these markers. And some of this is due to the number of projections that were able to be determined on these markers. So if you click Filter Photos by Markers, you can see that some of these have gray targets here. Because of the orientation of the target, it is difficult to see exactly where the marker could be positioned. I don't like this image, so I'm not going to update that one. Let's see. We can attempt to put it in the center of these targets, and that changes it to green. So that is now a well-defined point for these markers. Because even though I gave it its best guess, it might not have been exactly correct. So that's how we can update these when you have to target. The green flag indicates a positive marker identification, whereas a gray flag indicates a possible suggestion for a marker position. We were able to accept the marker by moving the marker position to the new target location. So when you position the scale bars, it's important to position the scale bars for maximum accuracy in both the horizontal and vertical axis. And one caveat that has affected me before when trying to capture images is that if you are attempting to do smaller objects with a high resolution camera, the software may not detect the coded markers. One of the reasons for this is that there are too many pixels across the markers in your image. The limited Metashape is a 60 pixel diameter from one side to the other of the marker, and at this point here with these images we were 20. So now that this is done, I just wanted to show how to set these markers. You can go File, Export, Export Points, and then when your points are exported, you can generate another model and you can take measurements in this model to determine the exact height from the bottom to the top, dimensions, distances, and total overall length. You can see the overall length of this is 194 meters from this end to that end. And so that's the big advantage in putting dimensions in your model. All right, thank you.